Guys, you hear the good news?
No, what?
Hockey's coming back, baby!
Formula One is very much defined by its superstar drivers, Hamilton, Schumacher, Senna. These names loom large over entire eras of F1 racing, but while it's the drivers that get the adulation, the legacies, and the lucrative watch endorsement deals, above all that, Formula One is still a team sport. F1 2020 is without doubt the most superb interpretation of that yet, bringing a satisfyingly deep management angle to the most feature-filled Formula One game I can remember. Formula One really is much more than just driver versus driver. It's organization versus organization in a checkbook-shattering technological arms race, and F1 2020's fantastic new My Team mode is a wonderful and addictive representation of this war over precious milliseconds. My Team stands apart from past F1 career modes by casting players as not just a driver, but as a team owner too.
What's very special about this team, though, is that while the team itself is new to Formula One, so too is its driver and owner.
Where previously we've needed to choose and join an existing team as a driver for hire and hop between them as the opportunities arise, F1 2020 allows players to follow in the footsteps of greats like Sir Jack Brabham and Bruce McLaren and build their own personal race teams around them, all while still taking to the track every race weekend. While past F1 career modes have allowed us to control car upgrade R&D on behalf of our employers, giving drivers at least some influence over what happens off the circuit, My Team massively eclipses this. You need to build a brand new team from the ground up, effectively becoming the 11th team within the F1 Championship. That means choosing team colours, assembling a logo, signing a power unit, securing sponsors, honing a livery and matching race suits, contracting a second driver, and watching your finances as you attempt to grow your organization into an outfit that can challenge the established powerhouses. My Team adds a huge amount of longevity to F1 2020. I've never hit the 10-year mark in previous F1 games, but I could here. And it's not just because there are visible things to spend vast sums of your sponsorship bucks on, like upgrades to various parts of your business, including bigger and better simulators and fancy wind tunnels for your aero boffins. And it's not just because the finite number of days in the F1 calendar means it's a constant juggling act to schedule everything from training for your second driver to team building activities for your various R&D departments. It's because the sense of ownership over the destiny of my race team is something unique to F1 2020. Previous F1 career modes simply haven't been able to produce the same emotional connection. When my first driver refused to re-sign after our debut season, after all the time I dedicated to boosting his stats via training, I was pretty bent out of shape. How dare he? After everything Jack Speedweasel Racing did for him? Seeing him finish last in the first round after leaving my team was surprisingly satisfying. Yes, the livery selection scope is ultimately pretty narrow. Yes, it's a bit silly that showing any kind of specific attention to one department makes the rest of your staff grumpy, like they're a bunch of 5-year-olds who missed out on a cookie. Yes, some of the recycled cutscenes clash a bit with the fantasy of you being the boss now.
A lot of our hard work could be undone if we're not careful, so let's figure out how to mitigate this.
Carl, mate, I'm not just one of the drivers. Whose name is on this building?
Alright everyone, let's get on top of this.
But minor grievances aside, mixing a robust motorsports management experience with the series' existing brand of excellent on-track action means My Team isn't just the best thing Codemasters has ever added to its F1 franchise. It may be the best addition to any F1 game since Psygnosis coaxed Murray Walker into a sound booth back in the late 90s.
Much deserved victory and a brilliant performance from them all.
If additional team micromanagement isn't your bag, or you just bleed Ferrari red and could never imagine racing against them, My Team hasn't replaced the traditional career mode. It still exists as a separate mode. Like last year, you can start with a small F2 appetizer, though you can complete a full season of it this time, if you wish. Failing that, there's still the regular championship mode where you play as a real driver in a fantasy version of the 2020 season. You know, the one that was going to start in Australia instead of Austria. Either way, there is no shortage of content in F1 2020. Perhaps best of all, however, is the return of split screen. And yes, it seems a little silly to celebrate something we had back in 1996, but I've had a hoot playing F1 2020 split screen with my kids. You can choose any driver and car you want, but we've had fun turning the split screen into a bit of couch co-op by racing on the same team and striving for 1-2 finishes. I did glance down at one point to find the AI struggling to extract themselves from a monster wreck at Monza my son found himself caught in, but he was howling with laughter at the time, so well played, Codemasters. After all, as a great man said, anything can happen in Formula 1, and it usually does. The inability to mix the excellent standard simulation handling with the new, more forgiving casual driving model in split screen means adept F1 players will probably need to crank it down to casual to share the track with the very young or inexperienced, but it's a little sacrifice for a lot of fun. The casual driving model provides a helpful friction assist for off-track excursions and an automatic respawn feature for F1 newbies. But F1 2020 caters for the other end of the spectrum too, with better grip on corner exits and a more realistic ERS deployment mechanic with the function mapped to a single, more authentic overtake button. There are also neat, nerdy touches like the ability to fiddle with the HUD and fully customize what you want on screen.
You've been superb all season and you've got your reward. You are the Drivers' World Champion.
F1 2020 is simultaneously the deepest yet most accessible Codemasters Formula 1 experience to date. The heavy reliance on recycled vignettes and the same old faces we've been seeing for virtually an entire generation admittedly means F1 2020 doesn't necessarily look as fresh as it feels.
All right, good morning, everybody. On this Tuesday, as always, please let me know in the chat that you can see and hear me before we continue. All right, sounds good. So, on our schedule today, we have ideally chapters 9 to 11. Now, it might seem like a lot, but it's really not. We'll summarize all the things that we need to focus on coming out of these chapters. So there are just a handful of things, really. The divisibility chapter is very descriptive and detailed, it might seem, but the things that we have to be able to do, it's not that much. So first of all, we have to review long division. So let's maybe summarize this over here. So we have to do long division to find the quotient and the remainder. That's the first thing. And that quotient and remainder allows us to expand on a number using the quotient q times b plus r sort of format. So it might seem a little weird when I look at definition 9.11, but it's really just technicalities that the remainder will always be less than the second number, q is called the quotient, and so on. So let me know if there are any issues with long division itself. We kept that separate from our other three arithmetic operations because there was no need for long division in the other number systems. Then we got Then we get to the concept of divisibility. Essentially, there's no remainder when I do my division. And then I have my divisibility tests. So divisibility tests. And we have to know the tests for 2, 3, 4, 5, 6, 8, 9, 10, 11, and only those. So what do the divisibility tests do for us? It really just serves as a little shortcut that when I have a big number, and my question is only, uh, does 4 divide into this number? Then, if I'm only looking for a yes, no, I can use features of that number to quickly assess if the remainder will indeed be 0 or not. So little shortcuts instead of doing a whole division. So these are the divisibility tests I need to know. So given a number, if I look at an example, so there's a whole description, a build-up, going through them one by one, explaining why, with more detailed proofs than you need to know. All we need to know for a test is what is the divisibility test and can I use it. So I'm scrolling down to an actual example, not that one, like exercises 9.4 and 9.5, where we have to decide, is this number divisible by 2? If you say yes or no, then you have to also say why by referring to the divisibility test. The other kind of question is a nice one like exercise 9.5, where we're given a number and a digit is missing, but the number is divisible by something. Can I find the missing number in a more efficient way than just plugging in 0, dividing on my calculator, plugging in 1, dividing on my calculator, and so on? It's a little tedious and not insightful in any way. If I understand the divisibility tests, I can do this much more efficiently and much faster. So I like the exercise 9.5, which is a little bit more interesting than just asking for a divisibility question. So we have in one form or another our divisibility tests. Then there is some stuff on 7 and later on other prime numbers in terms of divisibility for interest's sake, but because the test for 7 doesn't actually save me any time, it's a little silly for me to memorize that. It's interesting that there is a test, but is it actually worth knowing? Not really. Then we have some problems there. I will say that problem 9.9 and 9.10 with multiple digits missing is bigger than a test question will be. We'll just have one digit missing. As soon as you have a couple digits missing, then it becomes a whole thing to figure out which one to start with and systematically reduce your options. If you have any issues with those bigger ones, you can let me know in an email. They take too long to do here, but you can easily make up your own. And for example, I can just make up one. Oh, 2,300 blank 1, and I want that to be divisible by, I don't know, 9. Can I find the missing number, the missing digit, and explain why by referring to the divisibility test for 9 in this case? I can easily make up a bunch of those. So we'll focus on just one digit missing. All right, so there aren't any problems I notice now like that, but it's so easy to make up your own and verify that they're correct. Then I'm just doing an overview here. while I'm waiting for specific questions, we move on to prime numbers. What is a prime number? So let's say here, prime numbers. Just what is the concept? What is the definition of a prime number? Do you know the first few prime numbers? And then in the book, there's an explanation of uh, sort of one of the first ways to sift through the numbers and find prime numbers left. And that leads us to a way, I'm just looking for, yeah, leads us to a way to figure out if a number is a prime number. So what is a prime number? Um, deciding, oops, let's say deciding if a number is prime or not by checking. For example, here's our example. That was an example as well. Oh, I'm just going to make it up, right? I don't know the large prime numbers. Let's say 7,321 prime or not. Then we have the visibility tests for a few of them. Yeah, I could look at the 21. No, it's not an even number, so that rules out divisibility by 2. I can add up the digits. I get 13, so divisibility by 3 and 9 don't work. So nothing obvious here comes to mind. 1 minus 2, 11 doesn't seem to work. So that sort of um, goes through all my easily known divisibility tests. So after that, I don't know. So I have to know, what do I test divisibility for? And that is all the prime numbers, 11, 13, and so on, up to some prime number p. And where do I stop? Where p squared is still less than or equal to the number that I test. So I have to know that only the prime numbers divisibility needs to be tested, and I need to know how far do I go in this list. Now this is just an example that might be a little bit big, but you get the idea. So that is the main idea that comes out of that whole chapter, but there's some discussion that's necessary. Then there are some significant results that there are infinitely many prime numbers, and any number can be written as the product of prime numbers in only one way. And there's an explanation of why, not quiz related, more just for interest's sake, if you're interested to see how do they even prove that these things are true. With a reference here, you see to deductive reasoning, things like that. It's all different forms of deductive reasoning, really. Then we have some problems that we can get to. That's just an interesting note on divisibility rules for other prime numbers. They can get to 7. Again, not quiz related, because it's not efficient, those divisibility tests. And then we get to our, scroll down here. Whoops. Come on. there, there we go. um, greatest common factor. Common factor. And least common multiple. Now, if you were to do these two at a low grade, then it wouldn't be done with prime numbers. You just make a list and find the common one, depending on which one you have to do. But as soon as the numbers get a little big or the lists become tedious and time consuming, then it's much more efficient to look at the building blocks of these numbers. In other words, the prime numbers that make them, and use that to construct the greatest common factor and least common multiple. I guess we should say here factor trees kind of come first to find the prime factorization and use that. And I think that's pretty much it. That's not a chapter 11 is not a big chapter at all. Yeah, that's pretty much it. All right, so that's our overview. We do have one question I see. Let me zoom out a little bit. Overview of the key things moving into the quiz. What we have to be able to do. Any questions on that list first? No questions. All right then. So let's see here. Where is problem 9.8, number 2 and 4? 9.8. Ooh, that's way up. 9.8. 9.8. Scroll here in a nice position. See if I can zoom in. Sort of. Sort of. So I will say that the propositions and things that were uh, discussed in the book, which had general statements trying to explain at some points why the divisibility test is what it is. Those are definitely a little bit more advanced. When I wrote this chapter, I guess I was a little bit ambitious, and I thought, let's just be complete. And if anyone has a question of why is the divisibility test for 9 what it is, then there's a full explanation. There's no mystery. But I then have to say, like I am now, that those general statements, those propositions, those proofs and general arguments to explain why they are not going to be in the quiz in any way. All we have to know for the test is what are the tests, and then we have to be able to use the test. So the number 3 and 4 in problem 9.8, they're sort of still remnants of older versions where it might seem as if I need to understand these general statements in testing situations, but I don't. We could still discuss it. But general statements like 3 and 4 will avoid because it takes time to really understand the language. And I have to say, is that really our focus for going into elementary school? No, I don't think it is. It is the phrasing, the language it, that is necessary to explain really why these things work the way they do, but that's a level that might not be necessary for us in general. If someone is really interested, absolutely, we can go to that uh, level, but it's not in general necessary. Uh, it's just good to see it sometimes, like, oh, I've seen how these things are phrased and discussed at that more advanced level. Like number 3, if I have 3 numbers and they are related, think of A and B as small numbers dividing into some bigger number n. A divides into n, B divides into n. Then is it always the case that A times B divides into n times n? So then I have to think about specific examples. Does it work? The more examples I make, they always seem to work. Then that's sort of inductive reasoning. Fair enough. It's not a proof. It's not 100% certain, but it does make me think, ooh, maybe this always works. Now, how do I go the deductive reasoning route to then prove that this always works? and those are a little bit more complicated, as you could see from little snippets in the book, demonstrating how it can be done in certain cases. And number 4 is the same. I have to be able to translate this first. What is this even saying? Well, if I have 3 numbers, A divides into B, and the B divides into some other number n, is it always the case that A divides into n? Now, we can have a casual understanding of this, slightly more casual understanding, by way of prime numbers and the concept of divisibility. If I have, I think it's still good to do, just have an idea of how prime numbers really determine the behavior and interaction of all numbers, because they are um, they are the building blocks of all these numbers. Let's suppose A is um, has a prime factorization, some prime numbers, P1 to P whatever, let's say 3, not a lot of prime numbers. If I then say A divides into B, that means, uh, let's just say P1, P2, and P3, right? That then means P1, P2, and P3 that occurred in making up A, they necessarily fit into B. Let's say occur in B as well. Now B could be bigger, so B could have other prime numbers as well making it, but at the very least, the parts of A have to be occurring in B because A divides into B. So it's sort of, when I think about prime numbers and the building blocks, it's sort of what fits into what occurs in what. Now, if B divides into some other number n, then all B's building blocks need to occur in n. Among those building blocks are P1, P2, and P3. So among others, P1, P2, and P3 have to occur in n as well. This is sort of a middle ground argument. It's not completely formally correct, but it's also not too casual either. And it's just the understanding of what prime numbers do when I'm talking about divisibility. So that means all the pieces of A occur in n as well, and so A will necessarily divide into n as well. If all its pieces are there, then it fits perfectly in to the bigger number. So there's some sort of middle argument. This is not a bad skill to have, but it's definitely not necessary. Just gives you a taste. And then you have to simply formalize this a little bit to actually make it a pure deductive reasoning proof. But let me know if you have any issues about that. If you're interested, you don't need to be. Number two. Number two. Ooh, that is a big number. So I want to know if this number, unnecessarily big, but whatever, if it's a multiple of 11. So I want to know, does 11 divide into this number? Well, what is my test for 11? Is the alternating plus minus of the digits, and then I evaluate that, what I'll call the comparison number. So that is going to be big. I'm going to move this so I can see it while I'm copying it down. Otherwise, I will not remember. So my number is, I'm going to space them out nicely. 2, 3, 4, 3, 4, 2, 3, 4, 0, 2, 8, 9. And I want to know, is that divisible by 11? Hopefully I copied that down right. So the first digit is always going to be a plus. First from the right, the ones digit, and then I'm going to alternate plus and minus. So we'll do that in a second. So that's going to give me what I call my comparison number that I'm actually evaluating. So I have 9 minus 8 is 1, plus 2 is 3, minus 0 is still 3, plus 4 is 7, minus 3 is 4, plus 2 is 6, minus 4 is 2, plus 3 is 5, minus 4 is 1, plus 3 is 4, minus 2 is 2. Hopefully I did that right. It's easy to get confused. This number is unnecessarily long. So we could say that since 11 does not divide into 2, we can even say it in words. Since 2 is not divisible by 11, the original number n is not divisible by 11, or we could say n is not a multiple of 11, or whatever version you want of that equivalent sentence. Hopefully my comparison number is correct. I don't remember the answer to this. But it's all a question of, do I know the test for 11 and can I apply it? That is, again, what we need to be able to do. All right. Hopefully that is a satisfying answer for you. Any thoughts or questions? Oops, where's my PDF now? Here's my PDF. There we go. Okay. So let's just make up a question here. Actually, I did one on this page, right? Let's do this one. Oops. Let's just do this question. 2,300 and something 1 is divisible by 9. Can we find the missing digits? I'm going to give you a minute. I just made up the question. Can you find the missing digits in a more efficient way than plugging in 0, plugging in 1, plugging in 2, plugging in 3? I'd be done by the time you're halfway, right? But everyone works at a different speed, so I'll give you a minute just to see what is the efficient way using the divisibility test for 9 to get all the missing digits, and then we'll do it. Just want to give you a minute. I'm not even going to do a timer, just to get you thinking for a few seconds first. All right, I'm just going to scribble it here on the side because I'm lazy. So let's name that digit x. So we have our number that we can refer to all the digits because the divisibility test for 9 has a calculation on the digits. So I add up all the digits. I'll call that my comparison number is 2 plus 3 plus x plus 1. So that is going to be 6 plus x. And I need 6 plus x to be divisible by 9. So then my options for x will, well, they could be more than one in some cases. My options are, I have to get up to 9, so 3, and the next one will have to give me a total of 18. That's too big, so it's only 3. But notice how I'm explaining how I'm using the divisibility number. Don't just say 3, because part of the marks go for explaining and verifying that you understand why it is 3. You really only get half the marks if you give the right answer. The other half is for explaining how you get that answer, demonstrating understanding. Because I could just Google this, right? Or I could just test it manually. 0. Do my division. Nope, doesn't work. 1. For the digit. Do the division. Nope, I get a decimal. 2. That shows 0 understanding, really. So some more presentation needs to be done. Any questions on this little side example that we made? It's very quiet today, very quiet. As the weeks go on, it seems to be getting more quiet. And I don't know why. Well, I'll just talk to myself then, I guess. Let us see what else we have here. So we can do some factor trees, I guess. There's no other questions. Let's go to chapter 11. Now, if I just make up my own random numbers, they might not be very nice factor trees. So let's see here, what could we do? Problem 11.1. Which of these numbers are prime? And if they're not prime, what is the prime factorization? Now, something like number 1 is obviously not prime because they give me 2 factors already. So that's a little bit of a trick question, I suppose. Then if I have something like number 2, I can see obviously, well, that number is even. So it's divisible by 2. It can't be a prime number when it's bigger than 2. If I look at 127, maybe I don't know. Could be. Maybe. Maybe not. Maybe I get stuck and I need to go and verify what is the deal with 127. Because it's not as I can't just cheat and look it up and Google it. That doesn't really give me the explanation that I need to show in the test. So I'm going to try divisibility by 2, 3, 5, 7, and I don't need to go too high. I need to go to 11 because 11 squared is 121 and 13 squared is 169. That's too big, so I don't need to worry about that. And then I test divisibility. Nope. test divisibility by 3? No, because the sum of the digits is 10. 5 is a no, because the last digit is not a 0 or a 5. 7, nah, well, I don't have a test that's very convenient, so I'm just gonna quickly see. 7 goes into 12 once, then I have 57 left. No, that's not gonna work. So I don't even have to do a full long division because I don't really care what the answer is. I just care if it divides with a remainder or not. And 57 is close. It's not quite. And then 11. 11, my comparison number for 11 is 7 minus 2 plus 1. That is going to be 6. So that's going to be a no as well. So therefore, 127 is a prime number. So in some cases, testing the numbers in my list is super fast because I have divisibility tests for them that are convenient. Some cases, it's a little slower, but I show my work. I guess I should structure it a little bit better, but regardless, everything is there. I didn't do explanations for these easy ones, which I probably should have.
Hi,
Regardless.
Stephen. I just want to know for the quiz, do we need to show for each number, or we can, if we can, like just do it in mind, or do you want to show it for 2, 3, 5, 7, all of them?
No, I don't think an explanation for all of them is necessary. What I'm looking for in a question like this is, do you know which numbers to test? Do you know when to stop testing? And have you checked each one? You don't need an explanation for each one of these. But many people just test 2, 3, 4, 5, 6, 7, 8, 9, 10. Like, that's not what you need to do. You only need to test the prime numbers. Or some
Mhm.
people stop at 11. Let's suppose this was a bigger number instead of 127. Some people stop at 11 regardless because that's all they have divisibility tests for, and they think that's going to be sufficient. So we're looking
Mhm.
for, do you know to test only prime numbers? And do you know how far to test? How long that list needs to be?
So we don't need to show the detail for the other this thing. I mean, you'll know
No, I
gonna
just,
put the right numbers there.
yeah, you don't need to know. No.
Okay.
If it's a divisibility test question, uh,
Yeah.
focusing on one number, then we need to explain, but not in this one.
Okay. Thank you.
All right, so then I look at problem 11.1, number 4. Clearly, that's 11 squared. Number 5 is again a trick question because that's 31 times 31. So they already have factors. 31 is a factor. 1,247. I'm looking for obvious things and adding up the digits after I've checked the ones digit. 7. It's not ideal. Adding up the digits might be nice. Oh, it gives me a 14. That's not nice. So it's not going to be divisible by 3. It's not going to be divisible by 9. So now I start to wonder, there could be something that I just don't have a quick divisibility test for. The only one I haven't checked quickly in my head is 11. I leave it for the end because it requires a little bit more. 7 minus 4 is 3, plus 2 is 5, minus 1 is 4, so that doesn't work either. So I quickly run through all my divisibility tests, and if none of them work, which unless I've missed something, I don't see any one of them working, then I start to think, okay, I'm not saying it is prime now, but now I have to actually do a little bit of work. What was the number? 1247. So now I have to go and see, okay, I want to test 1247. That means I have to go through, some of them I've already done, I'm just making my list. 2, 3, 5, 7, 11, 13, 17, and so on. Now this one does seem a little big. Let's just try 7. I'm just sort of hopeful at this stage. 7 goes into 12 ones. Whoopsie. Then I have 547. So 7 goes into 54 7 times for 49. So then I have, oh wow, you really don't want to work. So 7 is a no as well. So far they're all no's. I think we have tested 11. And now for 13, 17, and so on, I don't have actual tests, right? So it's okay to just use your calculator. I mean, you could use your calculator from the beginning, really, but I like to practice my arithmetic a little bit when I have the chance. Otherwise, everything is just going to deteriorate very quickly. So I keep trying. Now we don't have to do the whole one. This isn't even a question. I'm just rambling on until someone asks a question. I try for 13, so I could maybe decide, oh, I'm going to use a calculator for that because 13 doesn't have a very nice convenient test in my opinion. Just to show something in the chat. Come on, you can do it. And I see, it's 95 point something, meaning there will be a remainder. So that's a no, and then I keep going. How far do I need to keep going is the question. Well, if there's a p here, and I need to keep testing until p squared, the prime number squared, is still at or below my given number, that's the same as saying the prime number should not exceed the square root of my given number. So I think I have a square root function in here. I haven't used this in a while. Let's see. No, that's not it. Square root, let's try that. Let me just test it with something easy. Okay, it is just that. Okay, so let's see what the square root of 1247 is. 1247, like so. Let's see. Come on, you can do it. No, you can't do it. It's not that hard. I just want to show it in the chat. Now MathBot does not want to play with me. Okay, I'll do it on my calculator. Just off screen then. Don't know why it doesn't want to show me an answer. It's not happy with something I did. 1247 is 35.3-ish. 35.31 and so on. So that means I need to not exceed with my list numbers past 35. If I've tested all the prime numbers, and you don't have to memorize them all, right? It's open book. I can Google the list of prime numbers to see that I don't miss one accidentally or whatever help you need. If I make my prime numbers and I get to, well, not 35, what's the first one? if I get to 31, that's going to be the last prime number I need to check. Past that, if any of them gives me a divisibility, a yes for divisibility, I would have caught that already in somewhere earlier. So it's important to sort of set this up and have your plan to see how do I determine when am I done deciding yes or no, this is a prime number. Just because I don't have divisibility tests for these larger prime numbers doesn't mean um, I shouldn't go that far perhaps for this number. So in this case, for example, you can keep testing, and I think you'll see 29 is a yes. But if I didn't know to go that far and make my list correctly, then I might have missed 29, showing that that is in fact not a prime number. Let's just see, why is MathBot not happy? It doesn't want to calculate the square root for some reason. Oh well, we did it anyway. All right. Let's see what else we could do. Let's go to some, I guess we could do something like problem 11.2 number 2. Actually, what were the numbers? 294 was already in the exercise, so let's maybe do the big one. I don't remember the answer anyway. That's it for questions. Oh, all right then. Let's do problem 11.2, number 3. Unless there are other questions, I'm not seeing any. Number 3. All right. Just double check. No one wants to say anything today. I don't know why. Did something dramatic happen? I don't think the tests were that bad. Number 3. What were the questions? 550. So 550. Well, I'm looking for the prime factorization. So, I mean, whatever comes to mind first, what I see first is 55 times 10. And if I can get the numbers sort of the same size, then it's just going to make the tree a little bit more balanced, but it doesn't matter. 55 can be 5 times 11. Well, it has to be. Now, each of these are prime numbers, so that part is done. And 10 is 2 times 5, finishing that part as well. And so 550 is 2 times 5 squared times 11. Can I just check? Can everyone still hear and see me? It feels like maybe there could be some technical issues as the
No,
reason no one is.
we can
Okay.
see you,
I don't
Stephen,
know. I'm just
and we
talking to
can hear
myself.
you also.
I get paranoid when I don't hear
We are in
anything.
class, Stephen.
So say again?
I said we are in the class.
Oh,
In
good, good.
school.
Okay. So now this one's a little bigger, so that's probably going to take me a while. I don't have the answer. I don't care to look at the answer. I want to make it, I don't want to spend a lot of time looking for something balanced. If I don't see it, I don't see it. I maybe don't see it. So I'm just going to go with 5. Not sure what's my calculator's deal. Let's try it again. 4125 divided by 5. Maybe it's happier now. It is. Okay, good. What's this line doing here? Eh. Okay. 825. So now if I pick a small factor, then the tree is probably going to be a little longer, but it doesn't matter. In the end, it's all the same. And I didn't quickly see anything else, so I'm just going to go with it. I'm not going to spend a lot of time making the tree as balanced as possible. That's silly. So here I could maybe do 25 to make it just a little bit more balanced. But it doesn't have to be. This line is always annoying. There we go. 25 times 33. Then the 25 is 5 times 5, finishing that part. 33 is 3 and 11, finishing those. That wasn't so bad. So I have 3 times 5 cubed times 11. All right, move this up a little bit. Now I want to build, I'll say, the greatest common factor of these two numbers. So now I have to understand, because I don't like memorizing without understanding. I want to understand what is being asked here. I'm looking for my answer to be a factor of both of these numbers, which means it needs to fit into the building blocks that I have for these numbers. But it has to fit into both. It has to be common. And then I'll worry about the greatest in a second. So I can't have a 2 because 2 doesn't fit into both. I can't have a 3 because 3 doesn't fit into both. I definitely can't have 5 and 11. So those are the only prime numbers that I can use to build my common factor so that it's still common. Now the greatest aspect of this is I want to make this as big as possible while still being a common factor. Now I see 550 has 2 5s in it, 4125 has 3 5s in it, so I can have 2 5s in my common factor and it will still fit into both. But I can only have one 11. There's only one in each anyway. Now calculate that or leave it like this. I really don't care. I like to just leave it like this. It's all the same. Least common multiple is, I wouldn't say the opposite concept, but in some ways, I guess you could see it. Sort of in contrast to this, I now am looking for a multiple, which means my given numbers need to fit into what I'm creating here. And that means I need to see a 2, a 3, a 5, and an 11. For 550 to fit in, I'm going to need to see a 2, 2 5s, and an 11. Now 550 is happy. For 4125 to fit in and be happy, I need to see a 3, I do. I need to up this number of 5s to 3 5s or it won't fit. So I'm going to have to do that, and it's happy with 111. So now that one is happy as well. I can't lower this in any way, or one of those numbers will not be able to fit anymore, and so I'm done. Done. So once we understand what the greatest common factor is asking for, the least common multiple is asking for, then building these shouldn't be a big deal. I see people just trying to memorize, oh, this is how I pick which prime numbers to put in. This is how I pick the exponents. I don't really understand what I'm doing. I'm just going to go through and do it. That's not really what we're here to do. We're here to improve our understanding, because how I'm going to, um, or what kind of problems I'm going to have in an elementary school environment can range from very, very basic to maybe a little bit uh, more involved with larger numbers. And I need to scale my explanation and my methods accordingly. And the only way I can do that with confidence is to actually understand what is going on. Even though maybe at a grade, maybe 4, probably not. If I'm looking for the greatest common factor, my numbers will be small, and they'll probably just make a list of all the factors and then pick the largest one that's common into both lists. That's a good starting point, but once the numbers get bigger, that's not really going to be very efficient. So I need a better understanding of how these things work in order to be flexible across different grades. That's pretty much the basics. I can't really think of. Yeah, there isn't even anything else, right? Chapter 12, we will wait for Thursday, but that's also a pretty small chapter. Let me just see, what are we actually doing for the rest of the time? So 12 and 13. What's 13? Oh, wow. I have no idea what 13 is right now. Oh, right. And after 13, we're into fractions, right? So we're wrapping up part 3 on Thursday. Again, it's not going to be a very big day. So if you feel like if you have to catch up or you want to get ahead, it's all good. We can certainly start dipping into fractions on Thursday, because it's a much, much bigger chapter, chapter 14, to give us a little bit of an advantage going into the last week. It's not a bad idea. And then officially next Monday is fractions. The day after, a little crossover, percentages, things like that. Then we will dip our toes in some algebra, and our test, the quizzes 3 and 4, will be Friday the 24th. That will be at 9 a.m., same as our session time. I just couldn't really put it on a Thursday because that sort of screws up our schedule and we might run out of time, because chapters 14, 15, and 16 are bigger than these ones are, and they might take people longer. Not everyone loves fractions. I know it's shocking, but some people need some more time with fractions and algebra and things like that. More advanced topics, I suppose. So if you feel that these divisibility chapters, especially what you need to know for the quiz, are pretty straightforward, feel free to um, go ahead and start chapter 14 so that you make your life easier next week. Yeah.
Stephen, where can we see the marks of the quiz 1 and 2?
When I grade them. Yeah.
And when will you grade them?
I don't know. Usually I do them pretty fast, but there's been more than usual a number of issues with people handing in late and having different reasons, and I just need to think a little bit, how do I proceed to be fair to everyone? Because some reasons are more valid than others, and some
Mhm.
people did submit it on time. I did say there will be penalties if you submit it late, so I just have to think, how do I proceed to try and be fair to everyone? Uh, so it's not quite as simple as it usually is. So it's going to be a little slower than usual, but I'm hopeful by Thursday they should be done.
Okay, we just go to the site and we just check the marks are there or not. That's the
Yeah, I
main
know.
country, right?
I'll
Because
maybe post in Discord as well when they're
okay,
up, so you
okay,
know you don't have
yeah.
to keep checking. Oh, refresh, refresh, refresh.
I
Um,
know that's what you. Because you're always
usually,
curious
yeah,
to know,
usually they are faster, but I just want to sort of double check that I don't miss anything uh, from different emails that I got and all kinds of things. And then it's more of a hassle adjusting marks after the fact. Um,
Mhm.
but by Thursday, I mean, you should know, right? You should have an idea of, oh, the quiz went well, or oh, that quiz did not go well. Usually you have an idea if it
Yeah,
was
but you're
okay.
still curious to know the
Yeah,
marks.
exactly.
Always
Yeah, yeah.
happens.
No, for sure, for sure. Yeah, I don't even know what else to say here. These chapters are, I don't know if they're really lower in quiz content, but they seem to always go much faster. Uh, as soon as we realize that we don't really need to know why a divisibility test work, I think I do feel better having seen why the divisibility test for 9 works the way it does. But there's a difference between having seen it once, feeling okay. There's a difference between that and being able to explain it myself on the spot. So I think that's not necessary. If we could just use the divisibility test, know what they are, know which one goes with which number, prime numbers, greatest common factor, least common multiple. That's pretty much it. Yeah. And the similar thing's going to happen for chapters 12 and 13. Once we get the hang of it and understand what we need to be able to do, then it becomes quite straightforward. But I don't necessarily want to get ahead of myself now. I'll stick to the schedule, with the exception of fractions. If there are no questions tomorrow, really, on chapters 12 and 13, then I might start uh, the discussion on fractions because I know that's a bigger one. And then we have the weekend to uh, really solidify that, and then we confirm um, everything on the Monday. That'll be good for fractions. So I might start with fractions tomorrow if there aren't any other questions, even though it's not officially on the schedule, just because those ones, 14, 15, 16, are definitely bigger ones that people are less comfortable with. But hopefully you can um, get through chapter 13 at least, and then know if you have any questions for Thursday. It's so quiet. I don't really see the need right now to ramble on for another 30 minutes. If you have questions, you can always message, you can always email. Um, Otherwise, I guess we will end it there. Are there anything that anyone wants to say right now before we finish the session a little early? And I'll get into the emails and the grading, I guess. No questions. You just want me to finish the grading.
Yeah, and it's all good, I think.
Yeah, no, I mean, admittedly, and some of these things might not be as new, and
Mhm.
that definitely does make it easier. I think things like factors, greatest common factor, things like that, people are more familiar with that, and that then does make it easier. Uh, yeah.
Yeah, but the video on divisibility was really good, although it was a little lengthy, but at
Yeah,
the
and
end
it
of it, you
has
feel
much more
comfortable.
detail. Yeah,
Yeah,
especially because it's explaining, okay, where does this test even come from? Trying to give it some context, why it is what it is, even though we don't
interesting.
need to know it. It does
Yeah,
help me remember a little
yeah,
bit, having at least seen it once. Yeah.
yeah, for sure.
Yeah. All right. I'll end it there. Maybe I can get through the test today. That is my goal. But worst case, uh, by tomorrow it should be ready. Again, if you do find chapters 9 through 13 very easy, absolutely, and you have the time, feel free to start the fraction chapter. It's just going to make next week easier. So we can definitely discuss fractions on Thursday as well. All right, I will leave you to it then until Thursday.